The textbooks by Rashid has a lot of worked over examples. These worked out examples, you got it. They are in OrCAD, in older version of OrCAD. As I said before, if you have an older version, you can run in the later version. Then these were done in like uh, version 9 plus something, and then you can use those schematic. You don't have to draw them again. You just modify something if you need to. And then let us go to take this. You start from this OrCAD. Once you start for the OrCAD, and then what you do, you go to you don't have to have a new start. You open a new project or open a project. You just go to this project. You go to the open a project. Once you go to the open a project, then let us say take this. I believe on chapter 4 a diode. I think it's chapter 2 diode maybe. Let us take this chapter 4 diode. They ask you to retain the old one. You say, I don't want to, I want to keep the old one, not to replace them. And go to the next one and then finish it. Once it's done, they ask me whether I should save it. I don't want to save it. I just want to, I just want to run the simulation. The you got like a, I said close it, and it has now converted the old one version into the new version. Let me go to the example. Let us go to the examples. You got example 4, and let's go to the page schematics. Once you go to the schematic, I should see the schematic now. You can see the schematic now. Now, when they did the conversion, it did a X. I don't know what it is. It doesn't make any difference to them. Let me view it, like zoom it a little bit, and then I can see it better. Then once I go to zoom it, and you can keep the X. It's not going to make any difference. Or I can delete the X, without deleting the one. Now I have done this one. Now with this one, I can find out whatever I want. I want to have this the biasing. Uh, I want to find the biasing. I could find the DC biasing. I could look into DC biasing. You could see these run the DC biasing, or I could go to the transient. Let us run the simulation. Run the simulation for it's set up for. I think it's set up for what sort of it's a transient analysis. It's going from 0 to 2 millisecond, and then it's set up for transient. I could run the transient analysis of the circuit, run the simulation, and as the marker is there, I should be able to see that coming up here. The output is there. You see that output. The voltage across the diode is there, and I could also see that what is the biasing current. I could also see the biasing current of the diode. I could see the diode biasing current, how many amps, 3.2 milliamps flowing through that. And that schematic, you can import, like I said before, to your Word document or whatever you want. You can just copy and paste there into copy that. Like this allows you to copy it, and then copy it, and then copy that one and take it to your Word document. If you need to go to the Word document, as I have the other document you have it open, you can copy that one. Okay, that is this one of the things. You don't have to waste your time in drawing another schematic. Let us take another example, like the bipolar transistors. I believe in chapter 6 or in chapter 5. Chapter 5, probably take a 5.9. If I take a 5.9, this is this same things we do. Cancel it. Now you have that. Go to the circuit 5.9, the page. This is the circuit I have. Okay, I got this circuit I have. It's like a biasing circuit, analyzing the biasing. Zoom it. For me, it's much easier to see it if I got to zoom it. Now this is the circuit. Is a biasing. How it is set up to do the operating point like this. You could see that it's set up for, I believe, the operating point. It's like a DC operating point. It's going to find out the DC operating point, and that's what it is. Okay, once you got that, we can run this simulation. It will find the DC operating point, and it has, because it has the activated this V and the I, and the V and I, you can see that VI, or the power, every resistance, you can find that one. And that is this. This is very simple. Again, you can take to your uh, you can take to your report if you want to put this one into a rockable. Let me see. It should show you. It should show all of them. Like you see that. You can if you it's 2:1, you can expand it to whatever they fit your screen. Okay. This is the second one. The third one I want to do to you. I want to see that. I think it's this one making the amplifier. Let us go to the project again. I believe one of them will be like 5.9, 5.10. Let's go to 5.10. If you go to 5.10, to convert it the same way. I don't want to save them, because if I save them, they'll create another folder. Let me log to the schematic. Go to the schematic. 5. This is the circuit I have. Okay. This is too crowded. Let me make it again. Zoom it. I zoom it here, and I can see it there. If you need to, zoom this one, right? And it is set up for, let us see what it is set up for. It is set up for simulation is done for to do the biasing, transient response. By the way, once you ask for the transient response or frequency response, the SPICE or any version of that simulation, they automatically do the biasing point, because they do the biasing point. Once they do the biasing point, they find out the biasing current and the voltage, and after that it creates a small signal model of the devices, okay, transistor or dot. And after it's done the small signal model, then that replace the transistors by model, and then it solve that one. By default, you have, when you do the transient analysis or the frequency analysis, by default that biasing is done. As a result, you have that biasing point. You can biasing voltage and current of the circuit you have. We have the previous one we have, and we don't have to get all of them again. Okay, this is what it is. Okay, now let us look through that. Let us look through this. The biasing is off now. It's not biasing. Okay, now the power. And like, look at that again. We look through that. They run the simulation for transient response. Let us look at transient response. And if you look at the transient response, this is the output is already marking across the load. We should get the output. The gain of the circuit here, you can read. You can read the gain of the circuit is about. Let us take this as a cursor. You take a cursor or take a cursor here. What is the cursor? You got a cursor. Put it, display the cursor, and once you go to display the cursor, you can find out the peak value of that. This is the peak value. You can find out the peak value, and you can mark that peak value. That should be able to level it, the mark that. You can find out how much is this. And I don't need that one. Let me take this this cursor out. Let me take the cursor out, and then take the cursor out. You can find the cursor out, and once I take the cursor out, you can see that the peak is like a 400. It's like a 30. It's like a 30 millivolts. Okay, I remember I put like how many volts was the input? Input was millivolts. That means that your output is 30. That means it's about 4. Gain is about 40. I think that's this is what it is. If you want to do this, you can adjust whatever you like, and then you go for the copy to the clipboard. Once you go to the clipboard, you can take to your Word document. That's what it is. Okay, I think that's very simple. And if you are already using a course, and if you are using this one, if you are using the OrCAD, and if you have those one, it will save you a significant time. I think I thought I'd let you know, and that's this. It's a very simple. You don't have to redraw them. You can modify the circuit. Is easier to modify than drawing from the beginning, and then setting up is also there. You can do. There are some examples of the sensitivity, and then Monte Carlo analysis, and many of them you can do that. I think that's the end of that. Thank you for